Welcome, everyone. Thank you for being here with us this afternoon. We are excited to share some interesting information we have here about scaling DI calculations using R with the DisImpact package. So I'll go ahead and turn it over to our presenters to go ahead and introduce themselves.
Hi, everyone. I'm Loris. I'm the Director of Research at Irvine Valley College.
Hi, everyone. My name is Vin Nguyen. I am the Senior Analyst in the office at Irvine Valley College. Very excited to be able to share some of the work that we've been leveraging here at the college that I think might be applicable to a lot of folks out there. So thank you for joining us.
Thank you. I will do a few introductions and then I'll turn it over to Vin. We've had a little bit of internet issues, so bear with us just a little bit. But we were very excited when we saw the DI webinar a few weeks ago with Craig Hayward and colleagues, and they highlighted an Excel sheet of how to calculate DI. And I specifically really liked the introduction, and I encourage anybody who has not seen it yet to go and look at the recording. Craig kind of showed the history of disproportionate impact analysis and how that has sometimes been misused and spread lies about something that looks very simple in a bar graph. So it really motivated me. There was also some discussion, and we've had these internal discussions about how disproportionate impact graphs potentially lead themselves to stereotype threat. So for people without context, they potentially then start treating students differently just because they've seen DI. So I encourage everybody to look at that or watch it again. It really motivated me and made me think more deeply about DI. But the second thing that came out of this is we wanted to highlight a package that Vin wrote that can scale DI calculations. I think the benefit of the Excel sheet is that it's very accessible to anybody with just maybe some small Excel skills. This here is intended more for technically minded people, researchers and others, and you can scale DI calculations, hundreds, thousands, 10,000s, whatever you want with just a few lines of code. So we're really excited to show this to you today. For those of you who want to get the DI setup, here you see the bit.ly links and the workshop files. Vin is amazing at creating how-tos that they're very self-explanatory. So if you have people in your office that have not seen this webinar, this is very self-explanatory, but it's not a requirement. Sometimes it is difficult to do it on your computer while also looking at a webinar. So these are just for your maybe later, or if you want to follow us through, that is great as well. All right, I'm turning it over to Vin. Here is our email address too, by the way.
Great, thank you, Loris, for the introduction and the context. So yeah, today's presentation is geared towards researchers and analysts, and the intent is that we do a lot of dashboard development. How do we go about doing it in a very efficient manner so that we could get more dashboards out to our stakeholders? So what you see on the screen here today is a very typical dashboard that you might have at your own college. So this is what we call our throughput dashboard, and it is in response to AB 705. We would like to monitor how throughput rates have increased or decreased or stayed flat through the years as we've modified curriculum and made changes in placement practices. So what you see here is by cohort year, the 1-year throughput rate for English. And what you see at the very top is the overall rate. And at the very bottom, what you'll see is these rates disaggregated by ethnicity. So, with equity, we usually want to disaggregate the results to see what if there are groups that are disproportionately impacted. So in this disaggregated view, what you'll see is that for different ethnic groups, they have their own lines. And what I want to point out is that for those with a larger bubble, this is based on the percentage point gap method, that using this particular methodology, we could say that this particular group was disproportionately impacted in that particular cohort year. So it's very nice. So when you present something like this, you see the overall rate, you see the disaggregated results, you see the equity gap, and the takeaway that someone might walk away from this presentation, from this visualization might be, look, we've been increasing our throughput rates through the years. If we disaggregate the results, you'll see that the rates increase with most groups. However, equity gap still exists and that certain groups are still disproportionately impacted, so that there is more work to be done. So when you share a dashboard like this, it's very common to get feedback in terms of feature requests or questions or follow-up questions that our stakeholders would like to ask. So for example, I'm going to illustrate how this version 1.0 of a dashboard might evolve with time. So we have it for math and English because that's what AB 705 calls for. A natural question that others might ask is, can we look at the overall throughput rate for both subjects combined? And can we break that out by ESL students? Because for English, ESL students are on a separate track. They have 3 years to complete. So sure, why not? So instead of just math and English, we might add in a few additional outcomes, math and English for ESL students. Loris, can you hit the next button? With that said, AB 705 calls for measuring throughput from the very math and English completion from the very first attempt of that particular subject. Can we measure it from the first semester of enrollment, which is more of a guided pathways approach, because guided pathways calls for English and math completion in the very first year. So sure, why not? We could also look at it from a 3-year perspective, because again, AB 705 for ESL calls for a 3-year completion, allows students to complete English and math within 3 years. So sure, we could add that. And then because we're looking at ethnicity, people could also ask for other levels of disaggregation. Can we break it out by age group? Can we break it out by economically disadvantaged students? Can we break it out by foster youth, military students, etc.? Sure, why not? We could build that into the dashboard. Another question might be, hey, AB 705 is for degree and transfer students. Can we focus on degree and transfer students? Sure, we could build that in. Let's add that as another filter. A common response when someone observes equity gap, a common observation that we've observed is that people would say, hey, the equity gap exists. It's because group X tends to be part-time students. So that's the reason why they're less likely to complete these courses. So a natural extension would be, hey, let's focus on full-time students. Sure, that could be another filter. And then when it comes to disproportionate impact, there are lots of different methods. There's three common methods, and within each of those methods, you could deviate from the standard assumptions. You could change reference groups, for example, in the percentage point gap method, as opposed to looking at the overall rate. And what I'm trying to illustrate in this first slide here is that as you develop dashboards, it's always going to be changing. Loris, could you hit the next button? And this is a classic example of death by 1,000 filters. And from an analyst perspective, what that means is that it creates a lot of work for us. So in this particular webinar, what we would like to do is to illustrate an approach that might help us scale out these DI calculation and dashboard development so that it take out a lot of the pain, so that we could spend more time making the visualization prettier, or more time talking with our stakeholders in how to close equity gaps. So in this slide, there's 2 approaches that I want to mention. The first is pointing to a student level data set and doing all the calculations inside the dashboard tool. With modern dashboard tools such as Power BI or Tableau, it makes it very easy for us to do a lot of these calculations in the tool. So it's very much kind of like Excel, where it allows us to write formulas and create lots of different logic in there. And that's makes it very easy. The second approach that we're going to illustrate is, let's move all that calculations outside of the dashboard tool. Let's instead pre-calculate all the calculations that we need, do all the disaggregation outside the dashboard tool, and just have a summarized data set, so that when we create the dashboard, we just point to this summarized data set, not have to do any calculations, and just visualize based on what's there. and both approaches are fine, but I'd like to kind of just highlight, the pros and cons for each. The first is very easy and it's doable. However, based on our experience, we found that using the first approach requires a lot of development time because we have to create a lot of formulas inside the dashboard tool. So if you're calculating disproportionate impact, you have to make sure your formulas are correct. You have to do it for different methodology if you choose. And if you're creating multiple dashboard, that increases the likelihood for error because you're reinventing the wheel or you're rewriting that logic in every single dashboard. You can't reuse that code really from dashboard to dashboard. So with that said, this approach might make it more difficult to debug because although we can write a lot of different formulas, one drop-down menu points to one formula, and that formula points to a second formula points to a third formula. It's really hard to debug when something goes wrong. And from a maintenance perspective, it might be very time-consuming. Usually, if that dashboard belongs to a single analyst, then it's perfectly fine. That analyst knows that dashboard in and out and can modify that with ease. However, in our field, in the IR field, what we found is that there are lots of opportunities from an employment perspective that analysts move on to better opportunities. So a lot of times we have to transition dashboards or projects from analyst to analyst, and that's where we experience a pain point where there's a lot of logic in a particular dashboard, but when it gets passed on to the next analyst, it's very difficult to update or maintain. And the last point that I want to mention here with doing everything in a dashboard tool or doing the on-the-fly calculation is that you're pointing to a student level data set. There's always a potential risk that that data could be breached, although I think that's very small, but because you're pointing to a student level data set, there's always that likelihood. Now, with the second approach, we have a very summarized data set, and essentially everything's pre-calculated. Every row that you see in that data set is a scenario or a data point that you're going to visualize, so that when you have that data set ready and you go on to develop the dashboard or visualization, it becomes very easy. You point a menu to a particular variable, and then you just plot out what it is that you want to visualize. And we'll get into this in a little bit more detail. Next slide, Loris. So what we want to share with you all today is this proposed workflow that we try to hopefully streamline the development of dashboards. First, we start out with a student level data set. We import this data set into R, and we apply just one function from the DisImpact package, and that's diiterate. And what it does is it disaggregates the data into various scenarios, calculates disproportionate impact using various methodologies, and spits out a summarized data set that you can use for visualization. And from that summarized data set, you just point to inside your dashboard tool and you can visualize. So here, it's a very simplified workflow. What we're trying to illustrate is that can we move 80% of the work in that first step, that student level data, because that's always a very time consuming process. Can we make it so 80% of the time is spent there, 15% of the time visualizing the data, and from a calculation perspective, when we disaggregate and calculate DI, make that just 5% of our time so that we reduce the complexity. Go ahead, Loris.
Just one question here. I got some emails asking if this is only available in R. And yes, this package has been written specifically in R and can be used only in R. We believe that the code that we're sharing should be able to be rerun or modified even for people with very limited knowledge of R. But I do know also that Stata and SPSS have kind of R integration packages, so you can run R within SPSS or R within Stata. We are not really experts on that integration, so if people are can maybe share in the chat or something like that, if they have done that successfully, that is an option. I know that R is not necessarily the choice for all analysts, but if you have questions on how to run it in R, or you run into issues if you're just starting up learning R, please let us know. But I just wanted to highlight that this requires R.
Yes, but I think if you jump back for a second, Loris, here we illustrate this workflow. I think it's going to be very dependent upon institution. So for us, that student level data gathering piece, for us, at least at our institution, that's a SQL query. And then once we import it into R and we spit out a summarized data set, we actually write it out to a sandbox environment, a SQL Server sandbox environment that we could point to. So for other institutions that could leverage this, you could use Excel for some of these steps as well, or you could use SPSS to gather your data, to do all your data manipulations to get it into a student level data set first. And then once you get to the R step, it's just importing that data set in, running the one line of code, and then exporting that data to the format of interest, and then you can go from there. So we think that it might be more applicable that way. Loris, next slide, I think we're going to pause for questions. So if there are any questions so far, we would definitely like to entertain them now before we get into the more technical part.
There's just one question in there. If this was also done in R, the visualization, but the dashboard that we showed is Tableau. So we use Tableau as a visualization tool. There is obviously many different ways of visualizing data like this. And then there was another question related to if we can share the links of Craig's presentation. I will find it. I don't know if Brad, if you can maybe help us with finding that. I know that has been shared in the Vision Resource Center. And I think it's also been shared on the R listserv, the RP listserv, but we'll try to get that link for the prior presentation as well. Are there any other questions? There's a couple questions that are coming in. What is the package for our iterate function? We will show you that this is the DisImpact package. We'll walk you through how to do that. Yes, the R syntax is available, so we will share the R syntax, or you will also see it. So we walk you through the R syntax, and the presentation at the very beginning had 2 bit.ly links, and you have access to everything through those bit.ly links. There's another question. Do you need to manipulate the data to all be the same before it goes into R, i.e. do you need to have all variable names the same?
So I could take that last question. No, the variables do not all have to be the same. Inside the function, you will specify the variable names so that the function is pretty generic. You just have to specify what are your success variables, what are your cohort variables, and what do you want to repeat by. So it doesn't have to be the same.
And thank you, Amber and Vanessa. They have shared, I think, the YouTube link to the prior presentation. And pasting the bit.ly links into the chat. Yes, we can do that as well. Maybe, Vin, could you paste the 2 bit.ly links in there?
Okay.
All right, let's continue.
Give me 1 second. Okay, Loris, I just dropped the 2 bit.ly links. The first link is to the setup, how to set up your R environment. And the second one is a link to this particular workshop, the scripts that we are going to run, and some sample data files that we could run. So Loris, I guess we could continue the presentation if there aren't any more questions. Let me check. There aren't any more questions. Before we get into the code, I just want to let people know this package that we're releasing in our office is released under the GPL version 3 license. And what that essentially means is that, look, we're not a software vendor. This software that we're releasing is free. You can redistribute, you can modify it any way you want. However, the point that we want to emphasize is that, we offer no warranty with using it. And what that means is that, we're not a software vendor where you can just call up and ask things. We're usually very responsive. If you have questions, we tend to answer that, so that's not a problem. But the important thing is if you're using this in your analytical work. We can't be responsible for the decisions that are made, or if there are any errors per se, we can't be responsible for that. So as you use this package, definitely check to see if the results look right to you. We do our very best to try to vet the calculations, and then sometimes we do discover bugs, and then we'll fix them out as each versions come out. So you'll see that we're at like version 12 right now. So we try to improve it and fix it and add features to it as we develop it. So that's just a forewarn. We're now going to go into the demo portion. Before I go into it, if you go into that second bit.ly link that I pasted, you will get a folder with some sample files. And we're going to focus on two files right now. The first is an R script that just says, hey, let's import the data, calculate disproportionate impact, and export it. So that's kind of like the easy step that we kind of saw in that workflow. And the second step is we're going to use that summarized data set, and we are going to emulate how one might use that summarized data set in a dashboard tool with filters and what's visualized. So hopefully we don't want to do that in the dashboard tool because every school has a different dashboard platform. So we figure everyone has Excel, so everyone could play with that. So with that, we can jump into it.
So I'll stop sharing and we can see if we can see your screen.
Okay, let's see.
Maybe I'll stop my video. I don't know if that will help. Yep, I see it.
Okay, you see my screen. All right, so if you open that workshop zip file and you unzip it and you open the workshop folder, you will see a few different files. As you see here, there's an R script 1, 2, 3, and then a few other files. So what you want to do is open up that first R script if you're doing this in parallel with us. And this is what you will see if you're running it in RStudio. For those that haven't installed DisImpact yet, you could highlight this line, which is currently commented out. You could highlight this line and have the DisImpact package be installed. So for example, I'm going to uncomment it and I can just run it once. And I highlight it and I just hit Control Enter to run the code in RStudio. And what it does is it downloads it and it'll install it. So, and you only have to do this once on your computer. So I'm just illustrating it for purposes. So here it's installed on our computer. Here I just want to point out what is our current working directory so that if you're writing any files out from this script, this is where it's going to be. So for me, it's located in my home directory in a downloads folder inside the workshop folder. So if you run that, if we write any data files out in this script, it'll be written there, just FYI. So now let's load the package. In R, to load a package, you just have to hit library DisImpact. I'm going to highlight it and hit Control Enter. And what it does is, hey, it's going to load these code into the R environment. And within this package, I've included a dummy or a fake data set for us to kind of explore the tool with. And that name of the data set is student equity. So if you do data parentheses student equity, what you'll see is it'll load that data set for us inside R. And for us, for those that want to see what that data set looks like, I'm going to run this line where we are going to view the data set.
Then you can also, sorry, if you go back to your code, maybe show that you can also click that run button at the top instead of Control Enter.
Okay, yes, so here, there you go. So this is what a student level data set might look like. So here I kind of emulated what it might look like at most institution. So here for every row, it is a student. And here you have some demographic information such as ethnicity, gender. And here I have cohort, a flag for transfer. Did this student transfer or not in a certain time period? Another cohort variable for when they took math. And then again for math, whether or not they've completed math. For English, and then you see a few additional demographic or student characteristics. Their EdGo, is it degree or transfer, or is it other? their college status. Is it their first time in college, or is it some other? And then you might have a student ID to kind of identify that student. So this to me is a very typical data set that we deal with in the community college system. And what you'll see here is, I created some missing data as well, because that's very realistic, right? Sometimes we have missing data. So in this case, this student doesn't have information for English because he or she never completed, have never attempted English. So he or she doesn't belong to any cohort and doesn't have any value for English. So if you go back to the R script, if you wanted to understand more about this toy data set, you can actually put a question mark, student equity, and run this line. We actually included some documentation. Sorry, it's not showing up here because I just reinstalled the package, but essentially if you run that line, if you restart R and rerun that line, what it'll show is the description of each of the variables in that student equity data set. So, and you'll see it on this corner. And it's not showing up because I just reinstalled it, so it's not there. So this is where we're going to do our DI calculation. We're going to use one function, and it's called DI iterate. So DI for disproportionate impact. And what we're going to specify is the name of this data set, which is student equity. And for us here, I want to demonstrate that, look, I want to do this analysis for all three variables: math, English, and transfer. So if you recall earlier, in this data set, there's math, that's a 1 or 0, English, that's a 1 or 0, and transfer, which is a 1 or 0. So that's going to be my success variables that I would like to do the analysis on. And in terms of disaggregation, what I want to do is I want to disaggregate by ethnicity and gender. So if you wanted to do it for 10 other different disaggregation variables, you can just specify them here. So if you recall, when I demonstrated the AB 705 throughput dashboard, we had DSPS, we had EOPS, we had age group, we had veterans. So you can pass additional variables here. But here, for the sake of this example, I'm just going to disaggregate by 2 variables.
And if I can just interject, just as a clarification, this package does not require you to have the exact same name for the variables. You can have, the name can be anything. So in that toy data set, it doesn't have to be transfer, it doesn't have to be math, English. You can, the name of the variable can be anything, and you just have to then change it in here in this, in the what now are highlighted as blue. So just know that you just need to clarify these ones, but you don't have to have the exact same data structure as you see in the toy data set.
Thank you for reiterating that, Loris. For this cohort variables, usually when we think of cohort, you can just think of it as a single variable. But here, the cohort actually differs because, again, from an AB 705 perspective, I want to measure math and English from the very first attempt, not from the very first time that they were enrolled. So for each success variable, I'm going to specify, hey, what is the cohort variable corresponding to that outcome? So here, cohort math corresponds to math, cohort English corresponds to English, and cohort corresponds to transfer. If I wanted to collapse them all by cohort, just that single cohort, I can just specify that single cohort and it'll also run. But here, I just want to demonstrate some complexity here. And finally, this repeat scenarios by scenario repeat by vars parameter. This one is just saying, hey, I'm going to do disproportionate impact analysis on these success variables for everyone that's inside the data set. But I also want to repeat that analysis split out by ed goal and split out by college status. So instead of looking at it college-wide, I'm going to focus on also those that have a degree and transfer goal, and I'm going to look at those that have an other goal separately. So again, this, if you think from a dashboard perspective, this is just one of those filters that someone might put down as a drop-down menu so that they can split up the data to look at disproportionate impact on a separate subgroup of students.
And this is a later addition to the package, because what we've noticed is as soon as you add one more filter, it's almost an exponential addition of calculations. So anytime you add one more ed goal, you then have to calculate every iteration of every single variable above that. So this is an extreme time saver that Vin added here, the scenario repeat by variables. You can add as many additional filters and add as many additional categories in those filters, and you don't have to, because initially our code, as soon as you added one more filter, just something that doubled and tripled, and you have 100 lines of code, which again, to Vin's point earlier, is very difficult to check for errors. If everything looks the same, except for one little thing changes from line to line, it makes it very difficult to error check. So this scenario repeat by variables is a later addition. So for any of you who have installed prior editions of the DisImpact package, please reinstall, because this is an extreme time saver, and it's really, really neat, because what you see here is essentially, 5 lines of code, and this will potentially create 10,000, 100,000 DI calculations for you.
So here I'm going to highlight this set of code and I'm going to run it. And what you'll see is that it's going to do a lot of data manipulations and return the results into an object called df-di summary. You can ignore all these joining by messages that are returned. It's just in the background, it's splitting the data set up by various scenarios. So I mentioned to you by earlier EDGO and college status, and then repeating this calculation over and over. So this is our summary data set. And if you want to view this data set, it's going to look something like this. I mentioned to you earlier that every single row is a scenario and a data point. So here in this row 1, the scenario is it's for degree transfer student. The college status is for first time college. The success variable that we're looking at here is math, and we're looking at cohort 2017. And the disaggregation is ethnicity. So if you look at this particular data set, you'll see there's disaggregated by ethnicity. So we have a row for Asian, a row for Black students, a row for Hispanic students, a row for multi-ethnicity students. So some relevant columns, N is the sample size, how many students fall into that particular group. Success, that's the numerator, so how many students were successful. PCT or percent, that's just the success rate, success divided by N. So this table just returns all the relevant information that you might want to either visualize or put in your tool tip that might be relevant from a user perspective. And then here, I mentioned to you earlier that this particular function calculates disproportionate impact using all 3 common methods, the percentage point gap method, the proportionality index, and the 80% rule. So here we also return some relevant information using those methods. So what is the reference for the percentage point gap? The reference group is the overall rate, the margin of error that's returned. So those are relevant, but you probably won't do anything with it. But what's important is this DI indicator underscore PPG flag. So for when it's a 1, it means that this particular group was disproportionately impacted for that particular cohort on that particular outcome. So here you'll see for row 3, which corresponds to our Hispanic students at our institution, they are disproportionately impacted based on the PPG method. So following it, it'll also return information from a proportionality index. So what is the proportionality index? And if using that method, if there are any groups that show up as DI. So here, most of these are zeros, but it'll be 1 when the DI method, the PI method shows up. And finally, for the 80% index or the 80% rule, similarly, some relevant information, and then a flag that says, hey, 1 if it's disproportionately impacted, 0 if it is not. And the intent of all this is that, look, you have all your information that you might want to visualize in one summarized data set. And if we go back, we can just export that data out. So here I can write it out to a CSV if I run this line, or you can export it to an Excel file. At our institution, I mentioned to you earlier, I would export that into a table inside our SQL Server so that our dashboard tool can just point to that and be updated. So with that said, so we've already written that Excel file out inside the workshop folder that we've provided. Now I'm going to pass it on to Loris to kind of explore that Excel file, and we're going to emulate how a dashboard tool might utilize that summary data set for dashboard manipulation. So I'm going to stop sharing, and Loris, I'll let you drive.
So Z had a question, is it PPG or PPG -1? So it is PPG for the general thing that we're showing. And after the Excel, we will show you how you can manipulate these overall, default settings to PPG -1 and many other different settings. So we will show you a PPG -1 option as well. Can you please share the 2 documents one more time? I logged in late and could not see them. Yes, please look at the bit.ly links that have been shared in the chat. You will see all the documents there. Do you also host the codes for this package in Git repo?
Yes, Paul, we do have it. So if you go on to the CRAN site for it, it'll point to the GitHub repo as well.
And Vin just reposted the bit.ly links. All right. For PI, is this threshold for DI 0.8? Yes, that's the default, but again, we will show you how to change default values. Any more questions? All right, so I'll share my screen real quick, just show you real quick again to kind of highlight what Vin just showed you. So here you see the Excel sheet that was exported from just those 5 lines of code. And here again are the individual returned variables that you will see by the DisImpact package. And one thing that is extremely useful for many of you who know that is, yes, you can, for instance, calculate, disaggregated rates. So for people who are very used to coding, but then you always have to calculate the all separately. So you have to calculate the disaggregated version and then the all version to kind of have both options in a dashboard. The cool thing about DisImpact does both. So here you see all, but you also see degree transfer and other. So even if you have a variable that just has degree transfer and other, you would have to separately calculate all, but the DisImpact package automatically will always create an all category for you and the disaggregated one. So it's very nice. So here you see an example. So you would highlight, you want to have all ED goals, you want to have college status all, so you don't want to focus on first-time college students, you want to focus on the English outcome, so have to complete a transfer level English, and you do not want to disaggregate. You see now 4 lines of code because 4 rows because you had 4 cohorts. So to Vin's point, every single row is 1 data point. So this is the data point for cohort 2017, 2018, 2019, 2020, and you have the DI indicator. So if you want to do the PPG one, you would highlight this row. If you want to do the other ones, those will be other one. And just as a quick highlight, how that would show up in a visualization. So this is just in Excel again. So you have all categories, and you have the none disaggregation. By the way, this none is also generated by the DisImpact package. If you don't want to disaggregate, you need to have a none category. And now if we click on ethnicity, now you see you have different ethnicity variables. So it's disaggregated by ethnicity. And if you go back to the data, if you do by the ethnicity, those are every single row here is represented by 1 dot here. So the 2017 cohort has 1, 2, 3, 4, 5, 6 data points. And so this data point here has 6 rows that are highlighted. We just wanted to spend a little bit more time to show you what the data structure looks like, but this also makes visualization very, very quick. If you do the on-the-fly calculations, let's say Tableau or Power BI has to always calculate the average and has to calculate the DI in the background. And we have some dashboards that do these on-the-fly calculations, and you can noticeably see a difference compared to if you visualize this type of data set. All the software has to do is highlight or visualize these data points, and it's very, very quick. As soon as you switch from one to the next, it is very, very snappy in terms of reaction time. So that's an additional benefit of using the DisImpact package. I will stop here real quick to look at the chat. Do you see any chat questions?
I don't see any questions at the moment. Does anyone have any questions? They could either drop it in the chat or feel free to unmute yourself.
All right, I'll stop sharing, and then I think the next step is to go into the more detailed specifications.
Sure. Let me see if I can share my screen. Do you see my screen okay, Loris and everyone?
Yep.
Okay. So we just had that. Before going on, I just want to provide some additional resources. In today's session, we're doing a hands-on tutorial, but we actually wrote up a few tutorials to get started with the package. They're in the form of vignettes. So if you go onto Google, just do a search for DisImpact CRAN. The first link that comes back is actually the package's homepage. Just click on it, and these two links will be there. The first one kind of gives you a review of the different DI methodologies and how to run them in R. And then the second tutorial is what we're covering today, which is how do we leverage this package to create dashboards rapidly. So I could demo that briefly to kind of just show. So CRAN, DisImpact, and it also goes to Paul's point. So this is the site's home page. Under this vignette section, you'll see two tutorials. The first one will give you this page where it kind of walks you through if someone from your office missed this meeting and they would like a tutorial, that's there. And the second is whatever it is that we're covering today, but in a self-contained walkthrough for you to kind of explore on your own. So it'll have code, it'll have results, and it'll have explanation. So hopefully that'll be useful for you all in the field. And Paul, earlier you mentioned whether this is on GitHub. So yes, it is. If you go on this page, it'll have the GitHub version as well. So with that, I will go back to the slides. I just want to forewarn everybody, this package is under active development. We're constantly changing it. When there's bugs that we find, we'll try to fix it. If you discover any bugs, please let us know. We'll try to fix it and roll them out for future releases. We're very open to feedback and feature requests. So a lot of the functionality that you see today, it's based on feedback and it's based on our work where we're like, oh, it's so painful to do this. Is there a better way to do it? So that's how that DI iterate function came about. It's because we were creating dashboards and it took so long, so we created that, and then we're talking, okay, there's different methodologies, let's do them all at once and then let the user decide which ones. So very open to it. If you have any feedback, please let us know. Just want to let you know that changes will happen. So sometimes we might have to make a change that might break your code in the future, but we'll try to not do that. So with that said, I'm going to move into the more some additional demonstrations. So inside your workshop folder that we've provided, we have a third script. It's called additional examples. And in this particular script, we will highlight how you deviate from the defaults that we've provided. So I think Z has already asked about PPG -1. So that's the methodology that says, hey, instead of looking at the overall rate as the reference, can we look at everybody but the current group of comparison? And we'll also illustrate custom reference groups, etc. So I'm gonna go through this briefly, if I could. So I'm gonna go back to my R session. I'm going to go back to my workshop folder. I'm going to open up the third script, and here we already have our data set loaded. I just have to load this dplyr to kind of help me illustrate a few points. So here, earlier you saw an example of how to run DI iterate with just the bare bones minimum. However, if you look at this particular function, it comes with lots of different additional parameters. As you see in the R console here, there's lots of different parameters. You could suppress the non-disaggregated results if you want. You could change the overall reference group. You could change different parameters in the PPG method, change different cutoffs. So here we're going to highlight that. So for question number 1, PPG -1, or in the scenario where you want to, for the PPG method, you want to, instead of using the overall rate, you want to exclude the current group, the group being compared to in the rate of comparison. So what you do is you just have to change PPG reference groups. Instead of the default overall, you would put all but current. So that's the parameter name for it. So it tells me that it's all but current. Everyone there? So I'm going to run this particular line. And again, it'll run. And what you'll see here, I'll just highlight it briefly, is I'm going to print out the first few observations of that run in this second line. And what I want to point out is that you'll see in the PPG reference column before, when we use the overall rate, you'll see the same rate being used when we're using ethnicity. Now, because we're going to use PPG -1, or we're going to exclude the current group, you'll see that this reference is going to change. So once we exclude Asian students, the reference for comparison is 79%. For Black students, the reference for comparison is 82%. For Hispanic, it'll be 84%, etc. So that's one deviation that you might want to use if that's specific to your institution. The second for the PPG method is, instead of doing an all but current, can we specify custom reference groups? And the answer is yes. So for example, for ethnicity, what if I want to specify as reference to be the white group for ethnicity, and for gender to be males? So I can specify it this way, and I could also run it. And if I run it, it'll also run like normal. And what you'll see is that in the results are going to look different based on the PPG method. So here, you'll see that the PPG reference group for the first few rows, instead of being overall or that all but current, it's now going to be white students, and the reference rate is going to be the same. It's going to match what's that for the white students. So it's 84%. So that's the reference that's used for comparison.
And I believe you need as many reference groups as are defined in the group variables. Is that correct?
Yes, Loris, if you're going to deviate.
Yeah, so if you're going to deviate, you have to specify the reference group for every single variable you specify in the group variables. So right now we have ethnicity and gender, so that's why we have to specify white and male. If you have additional groups, you would have to define additional reference groups.
And here you could specify it to be white. It could be white male, or you can put white, but for gender, you want to use the overall. That's also fine. You can put overall there, or you can put all but current for gender. So up to you, depending. But we've designed it so that it could be flexible and it could be used in a variety of different scenarios, because we know there are pros and cons to the methodology depending on your student population. So we've made it so that it's flexible for you to alter and adjust. The next is the proportionality index. Earlier, we had a comment to ask, is for the PI method, is the threshold for DI 80%? So we did use 80% as the threshold, but you could also change this to be 90%. You could change it to be 50%. So in this case, I'm going to change it to be 90%, and it'll just run and it'll modify that. And if I look at the first few rows, you'll notice now that using the proportionality index, the third row, which is our Hispanic students, is now classified as DI under the proportionality index, because the proportionality index is now 87%, which is less than 90%. When we used 80%, it wasn't declared as DI. So that's one example. Similarly, I'm not going to run the code, but I'll just show you for the 80% rule. 80% is the default threshold, but in case you wanted to change that as well, you can change it to 90%, you can change it to 50%, and that parameter is DI 80 index cutoff. And then for the 80% rule, by default, it compares each group's rate to the highest performing rate by default, and that's just based on how the methodology was described originally. Again, similar to the PPG, if you don't want to compare it to the highest performing group, you could also deviate by specifying white or male, etc. So you could also specify another group of interest to be the reference group. last couple of points. Here we've described how you could deviate from the default parameters for different DI methodology, but for a single methodology, let's say for the percentage point gap method, what if you want to run it for the overall rate and you want to do it for PPG -1, for example, or you want to specify a particular reference group. So how we recommend you to handle that is let's run it twice. The first scenario is when you run it by the first scenario that you want, which is the default PPG method, and then you'll run it a second time, and here you'll specify the reference groups that you want. So now what you'll do with these two results is you're going to leverage a function called bind rows, and what it does is it just stacks the two results on top of each other. And by doing it this way, you could get additional results using different scenarios for the methodology. And here I just want to call out that in the second call, I've suppressed the disaggregated results. And the reason for that is in my first run, I've already have the non-disaggregated results. So in the second run, I want to suppress it because I don't want a second set of rows that's going to be duplicated. So I'm going to suppress them. And if you run this, it'll just be longer. Here, if you compare the number of rows, so now it's like roughly twice as many rows there. I think there are some questions in the chat box, so I'm going to jump to them now. Or Loris, could you?
Yes, so I don't know if I understood Eric's question properly. So does it mean using the highest performing group when using PPG? I believe, if I understand you correctly, the PPG method by default uses the overall average, but you can change it to any reference group. I don't think, Vin, there is a way to define PPG by highest performing group, or is there, if you want to be PPG, the highest performing group?
You can do the highest performing group with PPG, and let me just show you that on the fly here. So how you would change that would be you would change, instead of all but current, you would change it to HPG for highest performing group, and you run it, and that'll use the highest performing group as the reference.
Wow.
And all
right,
these details, usually the documentation is all there, unfortunately, because I just reinstalled the package. It's not showing up here. Usually you can get help by saying DI PPG iterate, for example, and then it'll show up, and then the work function is DI underscore PPG. That'll explain all the parameters for you as well. So
maybe we have about 5 more minutes. Can you just show kind of the FERPA block? I think that might be something people are interested in. That will be very quick to show.
Yes, it's not necessarily showing, but I just want to mention to you that because we're displaying aggregated or disaggregated results, and we're doing a lot of different scenarios, as you can see, like in this typical example, it's like 890 scenarios. If you look at the sample size, for example, in the return data set that we have, 6% of the rows have a sample size of less than 10. And here I want to bring this to all of your attention because you have this return data set. You should have a process in place afterwards to create like a, whatever your definition of suppression might be. If you go with iPad's definition, suppressing anything with n less than 10, then you can create a flag so that you can filter out those rows. So if you go back to that AB705 dashboard that you saw earlier, you'll notice that in some of the lines, there's gaps in them or there's missing data. And the reason for that is because of FERPA block. We suppress anything that has less than n equals 10. So always check this because, this function is very easy to use. You apply it and then you might forget that, hey, you should suppress some data. So go ahead, Loris.
And I think for those of you familiar with R, it's very easy. You can also then just pipe it into either just removing those rows that have an n below 10 or you create an additional flag, so you mutate that the resulting data set, and you create a FERPA flag if you want to not remove the rows. But if anybody has questions on how to do that, please email us. I think we have just a few more minutes left. We want to see if people had questions or comments.
Yeah, happy to entertain questions. So let me see if I can bring up my chat, see if there are any more. Do you see any questions on your end, Loris?
I don't see any yet. If Brad has posted the link, we'll be very interested in seeing if you thought this is useful, or any feedback you have on the package. You can also leave comments. And obviously here are our email addresses. I think we'll stay on for a few more minutes for people who have questions. For everybody else, I'm glad to see you remotely. Hope to see you soon in person as well.
Just thank you everyone for your time and attention. We really appreciate it.